Hello viewers, welcome back to my channel. This is your number one stop for clear and simple maths lesson. If you are new here, this is Warren Science Academy, and in this video lesson, we are diving into a very important topic in Surds, which is rationalization. In the course of this video lesson, we are going to look at the meaning or the definition of rationalization, and after which we'll look at how to rationalize single surd. And lastly, we'll look at the rationalization by conjugate. So by the end of this video lesson, you will not only understand what rationalization means, but you also know exactly how to solve any exam question that involve rationalization. So I urge you to get your writing materials and let's get started. So we begin this video lesson by looking at the term rationalization. Now, rationalization in its simplest form means to make rational. So in this process, we are trying to convert something that is irrational to become rational. And in our first video lesson, I explained the difference between irrational numbers and rational numbers. And good examples of irrational numbers are root 2, things that won't give us whole number or fractions. So this can be root 2, we can have root 3, we can have pi as a good example. Pi is 22/7. And when you divide this, you are not going to get a decimal that has an end. You get 3.14 with some recurring decimals. So numbers like this, we term them as irrational numbers. Then good examples of rational numbers are, let's say, our whole numbers 5, 6, 10, or they can even be fractions like 2/4. And when you divide 2/4, you get 1/2. And when you divide further, you get a decimal which have an end, which is 0.5. Or it can be root 2 or root 4 rather, which will give you a whole number 2. So numbers like this, we term them to be what? Rational numbers. Then the ones that won't give us decimal with end, we call them irrational numbers, in the sense that their decimals keep reoccurring or it has no end. So the process whereby we can convert irrational numbers to rational numbers is what we term rationalization. But in the course of this video lesson, we are going to look at a special form of rationalization. So the rationalization we are talking about is simply the process of removing the surd from the denominator of a fraction. So we are removing a surd that is located at the denominator of a fraction. So that's basically what we are looking at in rationalization of surd. Remember that when you have a fraction, this line is the division line. So this line right here is the division line. So we have the division line. Then in a fraction, the number we have above the division line is what we rightly call the numerator. Then the number or whatever expression you have below the division line that is under is what we call the denominator. So in essence, when we are rationalizing a surd, we are trying to remove any surd that is in the denominator from that denominator. So at the end of the day, we are going to have something like this, 4 root 3/3. And if you look at this expression, 3 is no longer a surd, it is now a rational number. So we have simply converted this irrational number to a rational number through some certain steps, which we are going to look at in the course of this video lesson. Now, in simple terms, we don't like leaving the roots like root 2, root 3 as a denominator. So we don't want to see a root as a denominator. Rather, we want to remove that surd from the denominator and convert it to a rational number. So in essence, this is what rationalization is all about. So we move on to look at the rationalization of single surds. Now, why are they called single surd? Because you just have a surd alone as a denominator, for example, root 3 or root 2. It is not attached to anything like we are having 2 plus root 3. There's no plus or minus connecting it to another number. Or we have 3 minus root 5. So for these ones, they are not single because they are attached either by the addition sign you have here or the subtraction sign. So in essence, when you have a surd as a single surd, the simple way we are going to rationalize it is by multiplying the numerator and then the denominator with the surd. So when you have a single surd, just a surd that is not attached with either addition or subtraction, you are simply going to use that surd to multiply the numerator and denominator. So now let's look at this example. In this first example, we have root 3 as the denominator. So I'm going to multiply this numerator with root 3, and then the denominator with root 3. Now we are going to multiply. Now 5 times root 3 will give us 5 root 3. Now for denominator, we have root 3 times root 3. Now in our first video lesson, we established a fact. And what was that fact? We said root a times root a without solving, it is a. Just like if I have root 3 times root 3 without solving, this is 3, because it's a simple concept. Now we can pair this root. This will become root. Now 3 times 3 is 9, and then the square root of 9 will also give you 3. So without solving, when you are multiplying the same surd, just take out the number. So root 3 times root 3 is 3. So this is going to be our final answer. So in this case, we have removed this surd from the denominator, and we now have a rational number as a denominator. So this is why it is termed rationalization. Now coming to our second example, we have 4 over 3 root 2. Now the surd here is root 2. I'm going to use this root 2, not the 3, but just root 2 to multiply the numerator and then the denominator. So now for the numerator, 4 times root 2 give us 4 root 2. Now for the denominator, we have 3 already. Now this root 2 times this root 2 will give us 2. So that's going to be 2. Now we'll multiply further. So we are going to have 4 root 2. Now 3 times 2 is 6. Now when we get here, 2 can divide both 4 and 6. Now if 2 divide 4, that's going to be 2 root 2. And if 2 divides 6, that is going to be 3. So our final answer is 2 root 2 over 3. So this is what we mean by rationalization of single surd. So in essence, you simply use your surd to multiply the numerator and then the denominator. In the last section of this video lesson, we are going to look at rationalization by conjugate. Now there's a new term here, which is conjugate. Now what does conjugate mean? Conjugate just simply means the opposite pair and opposite pair. So if we have a male, the opposite pair to a male is a female. So the opposite will be a female. Similarly, if I have a man, the conjugate of a man is a woman. Or if I have a boy, the conjugate is a girl. Now, similarly, in mathematics, if I have addition, the conjugate of addition is subtraction. And also, if I have subtraction, the conjugate of subtraction is addition. So that's what conjugate means. So in this case, we are rationalizing by what we call conjugate. And why are we using conjugate? We are using conjugate because the denominator is no longer single. It is attached. Either we have it as a plus root b, or we can have it as a minus root b. So you can see that a here is attached to root b with what? The addition sign. Or in this case, a is attached to root b with the subtraction sign. So in this case, the denominator is no longer single. In essence, let's say it is married to something else, either with addition or subtraction. So when we say conjugate, what do we mean in mathematics? If I have, let's say, 3 plus root 2, the conjugate, let's take this as the conjugate, and let's have the expression on the other hand. So we have the expression here, and then we have the conjugate. So if the expression or the denominator is 3 plus root 2, then our conjugate will be 3 minus root 2. Now, if our denominator or the expression is root 3 plus root 5, then our conjugate will be root 3 minus root 5. Then let's say I have 2 minus root 3. My conjugate will be 2 plus root 3. So you clearly see that what we are doing here is that we are simply changing the sign from addition to subtraction, or from subtraction to addition. So that's what conjugate means. Conjugate just simply means the opposite pair. Now coming back, when the denominator is of the form either a plus root b or a minus root b, in this case it is no longer single, but it is paired with something else. Now we rationalize with the conjugate, and now we have expressed that conjugate is just the opposite pair. So we have some examples that we are going to rationalize, and the question says rationalize the following. The first question is 1 over 2 plus root 3, and the second question is 4 over 3 minus root 2. And we'll begin with the first question. Now, the first question, we have a denominator which is not single, which is 2 plus root 3. Now, the conjugate will be 2 minus root 3. Remember that when you have a denominator that is not single, you rationalize with the conjugate. And how do you rationalize? We multiply the numerator and denominator with this conjugate. So let's go. So we are going to multiply the numerator with the conjugate and also the denominator with the conjugate. Now for the numerator, 1 times this entire expression will give us 2 minus root 3 because anything times 1 is that same thing. Now in denominator, we have this expression 2 plus root 3. Let's take it in the bracket, which will multiply 2 minus root 3. So now let's work on denominator. Now this is what we call expansion in maths. And in expansion, what you simply do is this. You are going to use 2 to multiply this bracket first. Then afterwards, you use 2 to multiply this same entire bracket. So let's go. So we have this as 2 minus root 3 over. Now we are going to use 2 to multiply that bracket as 2 times 2 minus root 3. Then we're going to use plus root 3 to multiply 2 minus root 3. So we have it as 2 minus root 3. We are done solving the numerator. Now 2 times 2, that's 2 times this 2 will give us 4. Now 2 times this minus root 3 will give us minus 2 root 3. 2 is a whole number, so it's going to be outside. Then 3 is a sum. Now this is going to be 3 times root 2. So in this case, we are going to have 2 root 3. Then I'm also going to multiply 3 times root 3 times minus root 3. Now plus times minus is minus, and root 3 times root 3 again without solving will be 3. Now there is something I will let you know, which is this. When you solve, one of the surds should be a negative sign, the other should be a positive sign, and they should be similar. So minus 2 root 3 plus 2 root 3 is 0. So at the end of the day, we now have this as 2 minus root 3 over 4. We are left with 4 minus 3. And 4 minus 3 is 1. So we now have it as 2 minus root 3 over 1. And finally, our answer will be 2 minus root 3. Now, a simple trick you ought to know is that these two must be the same, this and this, because if they are not the same, they can't cancel that. And if you don't cancel that, you have not removed the surd from the numerator, because the goal is to ensure that the surds leave the denominator. So viewers, I hope you enjoyed this video lesson and you learned something from this video lesson. If this video helped you, please like, subscribe and share it with your friends. And also if you have any question, comment or suggestion, don't to leave them in the comment section of this video. So thanks for watching, and remember, maths is easier when you understand the concept behind it. See you in the next video.